Good morning. I am Dr. Tutakne from White Bengal College of Engineering and Management, Dongargaon, Nagpur, in Electrical Engineering Department. Today I am going to discuss about the power electronics, its overview, application and principle. As we know, the power electronics is used to control the electrical power, which is ranging from very low voltage to high voltage, and this is to be controlled. This is the job that is done with the help of power electronics. So electrical power processing is the another name that can be given to power electronics, because the job which is done in power electronics is processing of electrical power. It is not just processing the signal, but it is processing the electrical power, that is high voltages and high current required by the various types of load. So another thing that is done with the help of power electronics is it makes use of semiconductor switches. Means the power electronics is performing its work with the help of power semiconductor switches, and what it does the time ratio switching control. Time ratio control with the help of switching that is performed. So time ratio means on for some time, off for some time, on for some time, off for some time. This is the switch. This is making off state. This is in on state, making the switch off and on at variable on time and off time, variable on time and off time. That is done with the help of power electronics semiconductor switches, and this is switch that is known as time ratio control switches, and control output therefore is in the form of pulses, that is digital, and output that is available is variable, ranging from 0 to full value, that is analog. So that is the thing that is I wanted to insist, that input is digital and output is analog. Then what are the advantage of power electronics? It is having fast dynamic output response. Means whatever the output you want, if you want it in few millisecond or microsecond, that can be done with the help of power semiconductor switches, because they are having high switching speed. They can be turned on and turned off with such a high frequency, that is in one from few hertz to megahertz, 0 to 1 megahertz. That is the possible speed that can be achieved with the help of power electronics. That is why it is having a high speed dynamic response. Next advantage is it has got negligible control power. So for controlling, we are not using much power. It is just in milliwatts, milliampere, and range voltage range is 0 to 10 volts. So 0 to 10 volts pulses, and it is having power of micro milliampere, and therefore the power consumption is in milliwatt, and it is the power which is being controlled is of the order of few kilovolts or up to kiloamperes. So medium low power, medium power, high power, that can also be controlled with the help of signal which is having milliampere 0 to 10 volt. So control signal does not change, only size of the power semiconductor, ratings of the power semiconductor which it can carry, that changes. Control part is same whether you are using for medium power, low power or high power, and that is very less as compared to what power we are handling. Another advantage is economic and compact in size. So whatever output we are getting, we are the gadget which we are making is very economic, means it is having low cost, because it is having semiconductor. The cost of semiconductor is decreasing day by day. High power, it is therefore having high power density, and economic compact size means very less size and less weight. So this is the another advantage of power semiconductor switches. It finds application in domestic and industrial utilities. In domestic utilities, we we are having lighting, fans, which where we want to control, and in industries you are having electric traction, trains, metros, you are using industrial drives in various industries which are running different motors at different speeds, so motor control. So all these are the applications that power electronic circuit with very compact size it can perform or handle very heavy load, which is can be industrial or domestic. Another very important application is in power system. We can control the power of the megawatts from one source to another using the power electronic component, which is most important and most widely used component, that is SCR, silicon control rectifier. Another name is thyristor. So thyristor is the most important part, and now we are coming to block diagram of the power electronic circuit. It is having AC source or DC source. This source is to give the output to the load, and the requirement of this load is variable voltage and variable nature. So it can convert either AC to DC and DC to AC. So all conversion and control, both the things can be done by power electronic circuit as needed by the load. So this control, this is the block which is having power, and this is block which is feeding the pulses. So this is very less power block, this is very high power block. This is also source, and this is a source which is having fixed value. This requires variable parameter like variable voltage. So that part is taken care by the power electronic circuits using semiconductor switches. So these are the various applications. Another most important application is solar to power utilization. Now we are using rooftops and these things having solar panels which are having DC power. So DC power, but where we are using is AC power. So we need a converter which can convert DC to AC. So here there is a converter which we call as a solar power inverter. So that solar power inverter converts DC to AC, and the switch that is being used is another switch that is having its name power MOSFET. So power MOSFET is the most widely used device in domestic application. This has got very high frequency turn on capability, and that is being used to control the power with compact size. Another device which can be used for controlling the power is thyristor and diode, which is every house is being using this type of controller, that is your fan motor controller. So this is the fan motor which is shown by the road. This is the regulator that is there shown by the arrow. This is our AC supply, and the device in the regulator are trier and diode. So with that, these parts are power electronic part. They are inside this block, that is power circuit, and this forms the control circuit. This is a very simple and low cost circuit, and it is able to control the power of the fans which can run at variable speeds. How it converts? Here is the AC voltage. The AC voltage is shown over here. One, it is triggered after some time. So this time, from this point to this time, is called as firing time, or the angle, if it is spoken, it can be 0 to alpha degree firing angle. So maximum angle that can vary from here to here is 0 to 180 degree. If it is fired at this point, then output voltage will reduce. If it is fired earlier, then the output voltage will increase. The fan motor speed control can be controlled by giving the pulses which can be shifted from here to here. So if you shift the pulses with the help of R and C, the fan's output voltage will change from its shape from this output to this. If you want to further reduce the speed, you can bring this pulses over here and you can get the output voltage across this fan so that the speed of the fan can be changed. So this is the basic. I am telling you how the power electronics circuits are easily able to control the output voltage. So this type of conversion is coming under the category of AC to AC conversion. So as I told you in this block, this is converting AC and this is converting an AC to AC and the load is fine. Suppose the load is having DC. Here if you want a battery charger, if you want to charge the battery, if the load is battery or if the load is DC motor, so you require a DC output voltage. For that, this is the configuration. This is a center tap transformer which is having AC in nature and we are using two thyristors. One of the configurations, and thyristor is converting this AC to variable DC by controlling the phase angle control or firing angle. So variable voltage DC can be obtained across this load and which will finally control. If you are using a lamp, it will be working as a thermostat. If you are using a battery charger, you can use a battery instead of this load and charge the battery. If you are using a motor, then you can control the speed of the motor by controlling the firing angle. So this is the about firing angle control and thyristor. Now another switch that can be used is power MOSFET, and the applications of this in for solar and for motor control we are using IGBT. So this is the circuit which is shown over here is this is the IGBT switch. This is the DC motor, and from AC to DC we can control with the help of this power electronic converter with very less loss. So lossless circuit is this, and it is able to control anything to anything electrically. So anything means either AC is there, you can control variable DC. If there is a DC, you want variable DC, that also it can do. If you want AC and variable DC, or if you have DC to variable AC, then in that case we are using inverters. If you want DC and output is AC, that we call as inverter. We are using domestic inverter. And for that, what we have got the battery. It can be charged by either by solar or it can be charged either by the domestic charge electricity. When the power cut is there, in that case, this DC can be converted into AC and can be used in domestic application. If you want to feed it and to the grid, then it is known as grid connected solar power inverter, in which you can use and save the electricity by solar energy. So this has got wide application, and for that various types of power semiconductor switches are used. The different type of power semiconductor switches are, what are they? Power diodes, thyristor, triads, power MOSFETs, IGBTs, GTO, complete full form of GTO is gate turn off thyristor. Power MOSFET, power MOS semi-controlled field effect transistor. IGBT, insulated gate bipolar junction transistor, so known as IGBT. So these are the devices which are used as switch, and switch consumes less power, and therefore we can obtain any form of AC or DC supply voltage to whatever required by the load with the help of this, with very less input power and almost zero power consumption or negligible power conversion. If you are using rheostat in place of switches, then what you will get? You will get power control, but there will be enormous loss, and you will get power loss with very less efficiency and with more losses. Whereas if you are using digital switches, if you are using power semiconductor switches, in that case we can save the power and control very fast, effectively for all types of applications, right from low power, medium power to high power, ranging from volts, hundreds of volts, kilovolts, and up to transmission level 440 kV and current up to 100 kiloampere. So this is the wide range in which power electronics can be used and find its application. So I will be thankful to the management of the Vanganga College for giving me an opportunity to discuss about power electronics over. Thank you very much.